Welcome to the first tutorial in our Getting Started series. We will be creating a simulation of a simple gantry which moves boxes between two conveyors. We will introduce fundamental concepts such as navigating the user interface, importing CAD geometry, adding components, and writing scripts. The first step in the creation of most models is to import some CAD geometry. ProtoTwin supports the GLTF format. You can download the GLTF asset for this tutorial through the link in the video's description. Objects in the virtual world are called entities. Entities can be arranged into a hierarchy. The model hierarchy is displayed in the Explorer pane to the left. Select the main entity in the Explorer pane. This entity represents the top-level assembly which we imported. Selected entities are highlighted in green inside the viewport. You'll notice that the assembly is oriented incorrectly. This is because the CAD software used a different coordinate system. We can fix this by applying a negative 90-degree rotation about the x-axis to the assembly's transform component. All the components of the selected entity are displayed in the inspector pane to the right. We're now ready to begin adding behavior to parts of our assembly. We do this by adding components to the various entities. The first component we'll be adding is the interval creator component. This component will duplicate an entity every few seconds. We'll use this to create boxes, which will move through our model. Select the box, and then add the interval creator component to it. We can now run the simulation to check that the interval creator is working as intended. You'll notice that the box is being duplicated, but the duplicates are all on top of each other. Click the Reset button to reset the model back to its initial state. We want the boxes to obey the laws of physics, so we'll add a physics component to it. Now run the simulation again. This time you should see the duplicated boxes fall to the floor. Let's now add some behavior to the conveyors. Reset the model and select the belt of the first conveyor. We'll first add a physics component, which will allow the boxes to interact with the conveyor. If you run the simulation, you'll notice that the belt now falls to the floor just like our boxes. We want the conveyor to be fixed in place. Reset the simulation and set the body type of the belt's physics component to kinematic. Kinematic bodies are not influenced by collisions or external forces like gravity. If you run the simulation again, you'll see that the boxes now rest on the surface of the belt. Let's now make the surface of the belt move. Reset the simulation and add a transport surface component to the belt. Configure the leading and trailing edges of the surface. We'll drive the transport surface using a motor component, so click the button next to the motor property to create the component and automatically bind it to the transport surface. Change the controller property of the motor to velocity. The motor will now be controlled so as to achieve the target velocity, which we'll set to 0.5 meters per second. We now have a working conveyor. The next step is to stop the conveyor once the sensor at the end is blocked. This will allow the gantry time to pick up the box. Select the beam of the sensor and add a sensor component to it. If you run the simulation, you'll see that the boxes are now detected by the sensor. It's time to write some control logic. To do this, we'll create our own scripted component. Don't worry if you're new to programming. ProtoTwin is an excellent platform for learning to write code. The complete solution is available through the accompanying written tutorial, which you can find a link for in the video's description. If you get stuck, then you can compare with the provided solution. Open the script editor through the button in the toolbar and create a new script. We'll be creating a component to control the conveyor, so give your script a descriptive name. ProtoTwin will automatically generate the minimum required code for your component. All scripts are written using the TypeScript language. The component should switch off the conveyor motor when the sensor is blocked, and switch the conveyor motor back on once the sensor is cleared. So the component needs to know about both the sensor and the conveyor motor. There are a few ways to do this, but for this tutorial we'll add properties for these dependencies to the component. We'll use handles to reference these dependencies. Handles take care of observing the lifetime of the things that they reference. The basic idea is that if the object referenced by the handle is deleted, then the handle's value is updated automatically. Don't worry too much about the details at this point. Creating and using handles is quite simple. Start by creating public properties for the sensor and motor dependencies and initialize these properties in the constructor. Go ahead and save the script by hitting Ctrl+S on your keyboard. If you switch back to the editor, You should now be able to add this component to your conveyor. You'll see that the sensor and motor properties are displayed under the component. Let's just go ahead and configure the properties. Our component should now be able to access the sensor and conveyor components. Let's finish this component by implementing the control logic. Switch back to the script editor and override the initialize function. The initialize function is called at the start of the simulation. At this time, we need to subscribe for an event that is triggered when the state of the sensor changes. We can call the subscribe function, passing to it the object that we want to subscribe to, and the function that should be called when that object changes. Our function receives the current state of the sensor, which is true when the sensor is blocked and false when the sensor is cleared. We then just set the state of the motor to the opposite. So our motor will be switched off when the sensor is blocked and switched on when the sensor is cleared. Save the script and run the simulation. You should now see that the boxes are no longer falling off the end of the conveyor. If we move the box blocking the sensor, then the conveyor starts running again until the next box blocks the sensor. Things don't really get much more complicated than this in ProtoTwin. The control logic might get a bit more complex depending on what you're trying to control, but the principles are always the same. Let's continue with the gantry. The gantry has two joints. The first joint moves the carriage horizontally. The second joint moves the vertical rail up and down. Select the carriage and add a physics component. Now add a prismatic joint to the physics component. Prismatic joints allow the physics body to translate along an axis. Select the axis, ensuring that the arrow is pointing to the right. This direction represents our positive direction of travel. Click the button next to the motor property to add a motor component that is automatically bound to the joint. We're going to repeat this procedure for the vertical rail. Select the vertical rail and add a physics component with a prismatic joint. Select the axis such that the arrow is pointing down. Again, click the button to add a motor component that is automatically bound to the joint. There's just one thing that we're missing. The vertical rail needs to be attached to the carriage so that it moves when the carriage moves. To do this, we select the carriage as the base for the vertical rail's joint. Before we continue, let's test the gantry. Run the simulation, select the carriage, and enter a target position for the motor. Note that the vertical rail moves with the carriage. Now select the vertical rail and enter a target position for its motor. Everything looks to be working correctly. There is one last thing that our gantry is missing. It needs to be able to pick up the boxes. You can see that there is a suction gripper tool mounted to the vertical rail, so let's add a suction gripper component and configure its properties. Select the end of the suction cup as the position and a vector pointing downwards as the direction. Enter a value of 5 mm as the range. The range specifies the distance at which objects can be gripped. We'll also need to attach the gripper to the vertical rail. To do this, add a physics component with a fixed joint and select the vertical rail as the base. We now have everything that we need to write our control logic for the gantry. Let's go back to the script editor and create a new component. Just like before, we'll declare our dependencies as public properties. The component needs to know about the sensor, the carriage motor, the vertical rail motor, and the gripper. We'll again use handles to reference these dependencies and initialize the handles in the constructor. The control logic for our gantry is a sequence of operations. The built-in sequence class is designed for exactly this type of problem. Override the initialize function and create a new sequence. Note that we pass true to the sequence constructor, which makes the sequence cyclic. The first operation in our sequence is to wait for the sensor to be blocked. We'll add this operation to the sequence. Once the sensor is blocked, the sequence will move to the next operation. That operation will be to move the carriage so that it is directly over the first conveyor. We'll use the move to function on the motor, which should move the carriage slightly to the right of its initial position. The next operation is to move the vertical rail down so that the suction cup can make contact with the box. The next operation switches on the suction so as to grip the box. Once the box has been gripped, we move the vertical rail up, lifting the box above the first conveyor. The next operation is to move the carriage to the right, so that it is directly over the second conveyor. We can now drop the box off by moving the vertical rail down and switching off the suction. Finally, we move the vertical rail upwards so that the cycle can repeat. Switch back to the editor. Select the gantry through the Explorer pane to the left by expanding the main assembly. Now add the component to the gantry and configure each of the 4 properties that we defined. Let's test our work by running the simulation. Remember that the first operation in our sequence was to wait for the sensor to be blocked. The suction gripper looks to be working nicely. We just need to finish up this simulation by configuring the second conveyor. This one is simple because there is no control logic. We'll just add a physics component, making sure to set the body type to kinematic, so that it isn't affected by external forces like gravity. Next, add a transport surface component, so that the boxes can move along the surface of the belt. Configure the leading and trailing edge properties, which define the bounds and direction of the conveyor surface. Add a motor component. Set the controller property of the motor to velocity, and set the target velocity to 0.5 meter per second. We can finally add a deleter component to the entity at the end of the conveyor, which will delete the boxes as soon as they make contact. Make sure to set the geometry of the deleter component to bounding box. This short tutorial covered all the fundamentals, which you can apply to create your own simulations. Thanks for watching.